Hello and welcome. In this video, we will show you the process and evaluation of the static flux table test type. This test provides information about the efficiency and the losses of the motor and helps to match the controller better to the motor. This test is a so-called active test, which means that the motor is energized, getting the power out of the inbuilt industrial converter of the test bench. So for this test, the static flux table, we set in some metadata like the description of the test, the project ID, the device under test serial number. If this is correct done, we accept this, switch over to the DUT limits, select here the correct motor, the easy test motor, accept this as well, and go to the test case selection, which is out of the list here, the number 4 static flux table. We have to change the parameter sets to the test motor we use here. And we can see now here the configured test data, and we start the test. So the components are prepared, the safety circuit is closed, and the test will start. At the beginning, we have the phasing of the motor with a static DC current supply to the motor. This is also used for measuring the start temperature of the motor. Then we have a short warm run here at a low speed. And then we go up to the configured speed of 1200 RPM, which is used static in this test case, so we don't vary the speed here. We are in line 3, we see the current. This is the first low current range, which goes now over 7 points. And you can see that the torque range is going down while the D current is rising. After these 7 points are done, we go to the next current section, which also goes over 7 points. You see also the torque selection here going down from high to low. And this goes direct to the 3rd section, 4th section and 5th section. So if you see here in the 4th section that the torque is not visualized correctly, it's a little bit above that line here. So we can go to the left line here, press that button here, and it is configured down. So you can see all of the torque ranges here as well. Same situation now in the current line, press that button here and you are down here as well. And you can see that we are something in the range of 70 amps now. So now we see all 5 sections are done. The speed will go down here to 0. We have a last DC current measurement here to get the temperature results at the end of the test, and then the test is finished. We see the measurement path here where all data are in. We can open that folder, and at that moment we see all the raw data stored. We have the metadata here. We have a very intensive calculation running in the background with IMC Famos, and it will take something of 2 to 3 minutes to get the results done. So we see now that the PDF report is ready available, as well as all the other calculated data here, the result data. We open the PDF and we can see on page 1 the configuration of the test, but very important, the polar plot of ID and IQ. The red points are the measured data, which means we have the current variation from low current to high current over 5 points. And then we have the 7 points, which varies the D current in that section. The blue ones are the calculated points out of that one, which are used to get all the performance curves out of the test. We get the flux information of the electrical system, we get the ID, IQ variation over speed and torque here, and we get the electrical input power. We get the mechanical output power, as well as the efficiency versus speed and torque, the ohmic losses, the friction losses here, and at the last page, the timeline of the test itself. This easy it is to configure a measurement with IMC. In our further videos, we will show you more about our individual test cases. Thank you for your attention and goodbye.